Hi, thank you for joining me today for the adversarial tradecraft development in a nutshell. Thank you, B-Size Perth, actually for giving me this opportunity and hosting this great event.
Thank you for
Today we
joining me
will
today
talk
for
about
the adversarial
adversarial
tradecraft
simulations,
development in a
tradecraft
nutshell.
development, how
Thank you,
to
B-Size Perth,
interpret
the
the
trade
intelligence
intelligence
reports, and how we can start our development journey. So different types of experiences will be discussed. My name is Fatih Özavcı. I am a managing security consultant, also a security researcher specialized on adversary simulations. So I provided different types of research, tools, and activities to the community, and I presented in different conferences, including Black Hat, DEF CON, and some other major conferences as well. Firstly, we need to talk about the adversary simulations. Probably you hear about them a lot, but the colors mean almost nothing. We need to understand the context of them. Red team exercises are generally covert operations, and defense has no idea about that operation runs. Only some executives and the white team members will know. That actually limits the performance of the defense improvements. On the other hand, it is good representation of the threat actor targeting the organization. Purple team-like exercises, they are collaborative exercises and they provide more benefits. For example, improving the defense overall, simulating certain threat actor, and understanding the defense and proactive approach of the defense teams. That's why Purple team has more collaboration that gives more opportunities to different types of engineers, not only offensive engineers, but also defensive engineers such as incident response or forensics or threat hunting, or maybe threat intelligence teams as well. There is also automated approach for this. Automated approach actually focuses on the breach and threat emulations, and specifically demonstrating the threat actor behaviors. Sometimes this automated approach is quite beneficial if the exercise is targeting certain organization units or certain cyber analytics components. When we talk about cyber analytics, we need to elaborate that part as well. Cyber analytics is a new approach we see in the defense and large organizations. Generally, it is designed to identify the malicious behaviors on endpoints, cloud, networks, and different types of services. So simply, the organization will collect data from all units, so all ways will work efficiently, and they will ingest the data to a centralized data store. Then this data will be actually processed by machine learning algorithms, artificial intelligence, deep learning techniques. In the end, we will see how they work and what could actually go wrong there. What type of activities will be malicious? Who is targeting us? Those are the questions to be answered by cyber analytics. Of course, it has cybersecurity involvement, but also only data analytics, specialists working on the data interpretation or ingestion or making it efficient as well for the algorithms. It is important for us to demonstrate threat actor behaviors to improve cyber analytics in the environment as well. That's why we need to provide safer examples of the tools for them. Our development journey actually starts exactly that point, because we need to understand the threat actor behaviors and we need to replicate them. And that's why we need to actually open, read, and actually understand the threat intelligence reports. Threat intelligence reports provide indicators of compromise and also some samples of the command and control domains, CTUs, protocols, or maybe malware samples, or some of the code of the exercise as well. So simply we see some of the details of the campaign running for the target organization. Threat intelligence reports are generally limited or restricted because of the confidentiality requirements or the commercial exercises. That's why we need to actually work on different types of repositories to find the right data for us. And then we need to find examples. VX Underground, for example, provides a lot of malware samples coming from different campaigns, also some other exercise components and some malicious code as well. If we combine those two, we can understand how this threat actor tried to run this exercise or try to achieve their objectives. Then we can develop our own safe tradecraft to simulate this in the wild. Finding examples sometimes come from trusted or maybe semi-trusted researchers as well, and we can actually understand their code and we can customize it. All this journey requires actually development capabilities. That's why we need to understand the threat intelligence first. Threat intelligence is simply understanding the threat actor behaviors and then collecting the data to make them meaningful and trying to avoid the future compromises. That's why threat intelligence has different components. Sometimes it is day-to-day attack prevention, for example, IOCs of domains or hashes of malware or some certain features of the attacks. They are for daily actions. But if you have, for example, long-term goals, such as what threat actor targets us, how they change their game, what are they after? If an exercise is too long, for example, a year of exercise, such as Nobelium targeting SolarWinds Orion, that's a different story. And that's why we need to pay more attention to the details in that case. So we need to understand the tradecraft, what tools they used, what techniques they use, and how we can simulate them. In this case, emulating the actually threat actor and simulating, they are different terms. Emulation is simply replicating the behaviors of the threat actor. Simulations are more like building some similarities and using some approximation for the techniques and tactics. So different terms help us to find the right path and right solution for us. Offensive security leverages this threat intel and the other services to find the right approach for the adversary simulations. Offensive engineers read the threat intelligence data, understand their actually samples, techniques, tactics, and then implementations, and build their own actually adversary simulation or adversary emulation. If it is full emulation, they try to use the exact malware used by the threat actor, almost maybe 99% matching with the email or domain or the C2 software, trying to make it accurate as much as possible. Or we can actually add this with different layers, and we can use similarities. For example, we can use the same C2, but we can use additional tools, or we can change the approach. If the threat actor is using, for example, Excel4 macros, we can use Excel DDs as a replacement. So this type of activity is actually diverting the route and trying to achieve same objectives in a different path. And also there is IOC generators, and they are generally automated tools to actually generate the similar IOCs for you. Yes, it is the MD5 hash of the binary, but if the source code could be compiled in your environment, the MD5 hash will be different. So you need to focus on maybe fuzzy hashes, or you need to focus on the text of the file, and you need to build some Sigma or Yara signatures for it. So you need to actually understand what IOCs you need to generate. Then using this technique, you need to generate your examples. But the problem there is, where do you start? You need to understand, I think, firstly, the threat actor. Because if you work on threat actor, you need to understand what campaigns they have performed against different organizations and what are they after. Some of those are ransomware gangs and chasing some money and trying to get more money from different organizations, sometimes encrypting their disks, sometimes threatening them to release the data, sometimes just extortion. On the other hand, some of the threat actors have no interest in ransomware, and they are working for cyber espionage, and they are generally nation-state actors. There are also another types of actors, for example, initial footholder sellers. So they are actually reselling the organization they compromised. They don't have any interest to exfiltrate data or perform or run a ransomware operation. Instead, they compromise the organization and sell the success and do not involve any other additional activities. So different types of actors provide different types of tradecraft tools and tactics for us, so we can work on them. This is an example of attack, a very popular attack. SolarWinds has been compromised by a threat actor named as Nobelium, and Microsoft FireEye have been also involved in this case, and some of the government organizations in the US have been compromised. This exercise is a long-term exercise, and this timeline is extracted from Microsoft's threat intelligence report. As seen in this diagram, the attack takes almost a year. to design the attack, to plant a kind of malware to this environment, and seeing this environment for a short period, then understanding whether it is a target or not, then building a sleeping cell for a long term, and then initiating the attack at a certain point against all the targets already compromised, and not the targets in scope, because, not against the targets not in scope, because those targets were compromised, but they are there for another reason. If they could be compromised by the same threat actor again, that will be a kind of problem for the objectives. On the other hand, we need to understand how they approach this problem, because they need to compromise the software, SolarWinds Orion, and they need to stay under radar, but also they need to verify the target. And then they need to build a kind of sleeping cell. When the time arrives, only for the in-scope targets, they use a second C2 to deploy a payload, which is the beacon of the Cobalt Strike, which is the malicious software that starts actually interactive activities on the target system. All of this require actually 3 different C2s. One C2 is based on DNS for this exercise. And second C2 was a kind of web component. An interactive C2 is a Cobalt Strike profile and Cobalt Strike itself. To simulate this activity, we need to understand these details. Very same report, but this is this makes much more sense for us. If we pay more details, if we pay attention to details and we dive more, we can see some additional artifacts there. And we can start actually building a kind of map for us. This is a kind of MITRE-ATT&CK map, and some sections are extracted and trying to understand what type of C2 or exfiltration channels we can use and how we can build our own tradecraft. This is how I approach the problem, because we have trade intelligence data, we have samples, and we have MITRE-ATT&CK. So let's combine them to understand what we are exactly trying to simulate. Tradecraft details in the same document will also give examples for us, or maybe more precise content that can be simulated. Nobelium threat actor also tried to compromise additional units using an email campaign, a phishing campaign. And that's why there was another threat intelligence report released by Microsoft for this threat actor. In this exercise and this campaign, the threat actor used HTML smuggling to drop an ISO file to the victim system and then mounting it and opening this link to load the malware. It's a kind of content, but it does not make sense a lot, because we know and we understand HTML smuggling can be used. We understand the ISO, but how this happens, what are the details, how this link actually runs the DLL, and why and how? These are actually questions you need to seek answers while reading this threat intelligence report. When I pay attention, I see the content of the ISO file. So it simply says that there is a DLL generated, and there is a PDF file there, and there is also a link. And link points out the reports. However, it is not a link going to reports. The image looks like a shortcut for the directory, which is Explorer in this case, but the content is calling documents DLL and open, which is the exported function. Through that way, the malicious software actually is not identified because the exported functions are there, and the entry point of the DLL is not visible. That's a kind of problem for the antivirus to identify the malware. So EDRs can track this down. Now we have some details, but how this HTML smuggling works? What domains have been used? How this C2 communicated about? See, we are just actually digging more and more and more to find more IOCs for us to simulate. If we read details of the exercise, we can see HTML smuggling attacks details. We can see some code, we can see domain, and we can actually make this sense. And question appears that, where should we start? because we have three options here. One option is we can go to a kind of full simulation pack. We can go to our C2 and implant case and fire up the exercise, or we can develop some partial tradecraft. The benefits and actually consequences will be so different. In simulation pack, we have a kill chain, and we have some automation there, and lots of examples for the different stages of the exercise, because the exercise has full stack. In command and control and implant exercise, we develop or we repurpose an existing C2 for this exercise, try to make it relevant. For example, Cobalt Strike is heavily used by trade actors, which is fine, but they don't use Cobalt Strike as is. They actually modify things, for example, profile components, or sometimes even they change the beacon code. Recently, this has been done by a trade actor as well, and they use a different type of beacon. So the containers will change. If you want to develop your C2, you need to pay attention to different type of fundamentals and features of the implant and C2s. Another thing is we can develop actually partial tradecraft. For example, initial compromise of it, execution, evasion tactic, because the rest of the exercise will be so generic, but that part will give us a good attribution opportunity, or maybe that is going under radar and we need to make it relevant. We need to automate this until our applications, cyber analytics, learn from that. If that is the case, we can work on that partial tradecraft. We can work on that specific tactic. So let's work on finding examples. Because now we know that we use trade intelligence data, we read that, we understand the trade actor, and we know how to simulate it. But now, where can we find some examples? Because initial ones were coming from trade actor, right? One of those is understanding the actually impact of the trade intelligence report. If the report is so detailed, you can actually make it a kind of to-do list, just like this one. JavaScript that can actually decompose base64 data to dump a file. And this file will be an ISO file. And you know that the ISO file should include a DLL, should also include some additional link files, and maybe a PDF as well. And then you need to encode this as base64, copy the content to a JavaScript, and you make it an HTML content to be delivered to the client. That could be HTA file, normal compiled HTML, whatever it is, whatever you prefer, or whatever you see in the trade intelligence report. Some good researchers actually provide examples for different portions of the exercises. For example, Jorge Orchiles has provided Nobelium ISO example to the Red Canary. So you can review it and you can see that, how it is generated. Mehmet Ergene also generated HTML smuggling and ISO images for trade hunting to generate the similar IOCs. But you can see the difference between those two examples. One is prepared using a C2, one has different purpose. So you can see the differences between examples based on the same trade intelligence data. Also, Jean-François Mahé provided BER emulation there as well. So it gives you additional examples how you can make actually a DLL or some additional content for a specific content. If you are working on C# like me, you may need Adam Chester's research, C# DLL exports in this blog as well. So you are armed to develop some certain components for this partial example. Or if you want to go to your own C2, here is your own starting point. Patak C2 and implant is malware developed easily because they had no intention to make it a production exercise and production tool. That's why it has a lot of code mistakes, but it has also a good start for the initial developers. And it is coming with MIT license. That means you can repurpose it and make it your own. It comes with different protocols such as WebSocket, HTTP, HTTPS, SMB name pipe, TCP, UDP, implant-to-implant linking support on the implants. Also, additional components. So you can use this as a baseline for your own C2 or your own exercise. Or you want to use your own malware using another C2, for example, Mythic. Mythic supports custom implants, custom malware. So you can develop your own malware and You can use Patak actually as a malware instead of its C2. If that is the case, you can leverage some features of it. That means it can execute commands, it can execute, it can run processes, it can run a PowerShell or CMD commands using this new create process. It can upload, it can download, it can actually run some .NET assemblies in memory. It can compile them in memory and run. It can actually use .NET Direct to compile the content and give you just like PowerShell or maybe Python-like interactive shell. It can use actually PowerShell in system management automation. It can execute shell code using process injection. It has little movement example for WMI. So you have almost everything as a baseline though. It can automate things like that as well, because automation was the key for my exercises. I don't want to repeat myself again. Instead, I provided an automation support for Patak and make it a scenario. These are instructions and the commands for it. But if you are looking for more details, there is also a 40 minutes demonstration for you, if you like. In that link, that demonstration, I try to use Patak implant to run on Padme, which is a user running on Mandalore, which is a Windows 10, and connecting to the Patak service. Then we compromise Coruscant, which is another server in the back, and we link it using SMB name pipe using Patak. Then also we compromise Geonosis, and this time we'll link it using TCP 8000. The compromise is happening on WMI lateral movement techniques. In Geonosis, we also generate another implant because we need multiple options, and that's why we use internal mapping of SMB name pipe. And also we have another server, Nabu, and we actually compromise it through Geonosis and then link it to Geonosis as well. So as you see, there's a tree branching here, and we can actually run this as well. So if you like to get some graphical user interface, Patak is not your answer. You need something supporting a UI. In this case, I developed Tesat malware traffic generator, which is a defensive tool for cyber analytics to generate malware traffic. I mentioned this here because it is a part of my development effort for the adversary simulations as well. Sometimes we need friendly application that generates that malicious or simulated traffic, because we don't get approvals from everywhere because of this compliance requirements. That's why we need friendly interfaces, friendly applications. Tesat has a graphical user interface. As you can see here, Blazor UI has been used for it. It generates the source code for you, and it is a kind of bare bone for a C2. So you can add more protocols, or you can actually change the implant and make it interactive for yourself. So it is another starting point if you like. But if you are simulating an exercise, that makes it a bit complicated because you need to deploy Tesat in a certain location, and you need to deploy some redirectors to simulate some traffic like this. I have also a talk for malware traffic simulation in distributed networks. You can see details in that talk, but not here. We focus on development now. TA505 adversary simulation pack is a kind of end-to-end answer for you. So you have seen examples of partial development. Now you have also C2 and implant examples. You are looking for a full path for yourself. TA505 adversary simulation pack is there an answer for the TA505 trade group. If they upgrade their techniques against the cutting edge systems, what happens? That was the motivation and gist of this exercise. It was based on Windows 10 up to date. It was based on Windows Defender up to date, also Office 2019 with Excel sandbox enabled. It repurposed some of the UAC bypass, guest system token stealing, or some additional registry manipulations, and MC bypass as well, MC scan buffer patching actually. Those are repurposed, well-known attacks in the wild. This exercise also used some additional tools such as Patak. I tried to use this exercise to inform everyone, but also providing end-to-end example. This is the kill chain of the exercise. We simply provide a kill chain for the simulations, and this kill chain actually explains the levels of the complexity of the exercise. In this exercise, I try to develop some examples for different layers. So it provides you partial examples but also it gives you a solid C2 and implant as well. But of course, I made mistakes. I made mistakes by the design or by the decision. So simply, I had some different priorities to complete this exercise. You may not actually follow this one, but also there is 50 pages report as well as details of the exercise. So you can divert your path and you can see the improvement points I put there, and you can improve your exercise using the suggestions. I developed those 6 tools during the exercise. A malicious Excel file, I actually used ExcelNT Donut to generate this file, but simply this file uses Patak Dropper, which is a dropper, to actually load the additional components. It gets the MC patcher to patch the Windows Defender, then it loads the Patak implant. It actually loads after that a Meterpreter, Metasploit framework. It performs ransomware activities using Ransoblin, which is another custom application. So there's more than 4 hours video set for it. If you want to dive in, that is your path. How it can be developed from beginning to the end is available in this video. It is live recorded, so I made a lot of mistakes. So you can see my mistakes. They are not hidden. So learn through my mistakes instead of making it your own again and again. Just make your own mistakes, not repeat myself, okay? So simply read this content. And after that, watch the videos and make your own decisions to develop your own environment. Let's talk about the development effort now. So we know that we have different types of adversary simulations. We have threat intelligence to combine. We know that threat intelligence can be used to develop exercises. That's why we find some examples for different layers of the exercise, maybe some certain tools or a full C2 and implant or a full exercise end to end. Now, if we want to develop our own, we need to follow a couple of decisions. If we are going to designing C2 and implant path, we need to understand the essentials of this one. Firstly, you need bare bone implant, bare bone C2, bare bone protocols for you. So you can actually customize this. If you start from beginning, that would be so difficult. That's why I provided actually a tradecraft development trainings. And in my training and GitHub repository, you can find this training as well. I provide some code samples that I will demonstrate shortly. So you can build your implant to download some content from remote, such as social media, and run instructions. Or you can make it more complicated. For example, you can download instructions to connect the C2. Or you can actually make it way more complicated. You can get this data from a C2, for example, a payload server, and establishing an interactive communication with another C2, which could be a WebSocket as well. So these type of communications are important for the implant side. But if you are designing also a C2, you need to focus on some backbone features such as pluggable protocols for the services, profile support, credentials storage, data and load storage, logging, reporting. Those are the core components of the C2s. So you can work on it. And also you need to choose what abilities you expect from the implant, if you are developing an implant, of course. .NET Tradecraft is very popular these days. So if you want to follow a path for development, you need to go with whatever you are comfortable. Sometimes this is Go or Rust or NIM, but sometimes it is .NET. .NET is good for some cases because it is so integrated to Windows in several different layers, and it is very, very mixed in. So simply, it is well preferred, but it comes with drawbacks. For example, MC is attached to .NET after 4.8. That means if you see the CLR 4.0 and then .NET running on it, for example, 4.8, then you are dealing with MC in real time. Loading assemblies will be monitored. But for .NET 3.5 on CLR2 would be great for you to run the code with no MC integration. But this doesn't mean that EDR is not monitoring you. So lots of components are there, but .NET gives you platform invokes, direct integration, and also safer implementation. If you are not in hostile body, you can easily use .NET for Purple Team exercises if you don't have any concerns to hide your malware from elsewhere or any other parties, such as real trade actors. I have development repositories for all of those. So simply TA505 repositories there. We have C2 and implant, and we have TESAT as well. And now you have also an offensive development training, tradecraft development in adversary simulations from beginning to end. So simply ground to sky. You can easily develop your implant with advanced features as well. So I provide these examples for it for a reason. For example, this one is a simple demonstration of the simple components. These exercises are split to 4 chapters, and this video is for the second chapter. Simply, we have examples. For example, this one is check process. It's a simple class. You can add this to your code, and this will give you an idea of if a process runs or not. If it is running, that's something for you. Let's make it offensive. Check the process running or not, and the process name will be, for example, CrowdStrike, Windows Defender, or something like that. Then you can see that there's an EDR or antivirus running. See, it is easy. Web client gives you the web communications, and it accepts parameters, and then it actually retrieves some data from remote, and then parses this data, and then gets it actually instruction list. Interactive menus are also provided. For example, registry menu advanced is that file. So you can see the interactive menu there. But in this example, the web client is actually getting the data, and the data is parsed as input. So the interactive menu turned to a non-interactive menu through a web page. ASM helps us to load an assembly from local or remote. It's up to us. In this case, we use .NET. So we use client, download data, and it is URL. That means we will use .NET Web Client. If it would be a file, we could download the file from the local path. What it does is simply executing the .NET assembly or compiling the source to make it running. And in this case, everything happens in memory. And you have examples of the content to write to the files. You have also examples of compiling a .NET application, and you have examples of how to run a third-party .NET code with no information, but in your process. So examples are there, but if you want to go back, the chapter 1, there are way easier examples, and it starts with hello. So I don't know where you want to start from, but this is a good example that actually gives you opportunity to customize your code. For example, this part is so easy to run .NET code segments because it gives you only 5 lines to run this, and it is so easy to understand. If you go to the WebSocket implant, the objective will be changing slightly because you make it interactive socket. So you can use this socket as is in your environment, and you can make it an interactive component. So simply your malware will be connected to you using HTTP or HTTPS, but top of it, HTTP WebSocket. Just like the TCP sockets, it will be in real time. And it is a native HTTP protocol, so you don't need to justify your scenario. It could be like an API or a kind of web chat or something like that. So it blends in very fast. Then processing the instructions. It is that easy. It is not that complicated. It is easy. So simply your menu this time driven by a kind of WebSocket service. I also provide WebSocket service for you, so it can be identified through that way, and it can run. And this service socket is simply creating a new socket for you, and then listening to the implants connecting. When the implants connects, you have interactive menu again to run on it. So it's up to you again. What you want to do is really unlimited. In this case, instructions would be a kind of landing page for you, and then you can add your other instructions. For example, inject payload, inject content, run this command, get this command, check the process running. But every part of it are actually split up to gadgets. That's why while developing, I use generally gadgets and make them actually working just like Legos. This is the chapter 2 content. So we can actually compile the content using Mono or the native Windows. In that training, you can see the details of various options, how we can compile them and how we can run them. This is an example of web client compiled. And if we use the same repository, you will understand that there is also a C2 like text file there. So you can use that text file as a C2. For example, running those commands will help you. You can download the text, or you can give that content to our web client directly. So it's up to you. Our web client was downloading a file and running it, right? So if we give a URL to our raw assembly file, it should run it. That's the scenario. So that's what we expect. So our malware initially has no malicious intentions, but it goes internet, downloads another actually executable, another .NET assembly, loads in memory and runs this. See, it makes it malicious from now on because we have a third-party code coming and in memory, not on disk. That's why antivirus doesn't understand this. But EDRs still monitor, and that's another case that we discuss in that trainings later sections. Another example is WebSocket. WebSocket is the interactive example for this one, because in the WebSocket, we simply make it interactive and real-time. That's why it needs a service this time, because initially the web itself is HTTP file, and it can be any file, text or binary or regardless. But in WebSocket, we need to host something and we need to wait for the connection. In this case, I use .NET WebSocket service, and it will be running just like .NET Run. So you can start actually modifying it, and you can run it as .NET Run. It can work on .NET 2.2, 3.1, and .NET 5 as service. So you could be quite flexible for the server component. As seen, you are actually on a shell and waiting for an implant to connect. If the implant has the classes I pointed out, the implant can connect to that URL. That URL is WS, by the way. It can be HTTP as well. For executables, you need to use Mono on Linux and Mac because they are not native Windows. As we see, it is connected to our web server environment, which is WebSocket, and the implant is there. When we hit the commands, we see the implant is actually running those instructions. So you can take it from there, and you can actually advance it. Now, let's move on. What we can do more? Patak has individual capabilities. It is coming with the same training as well. And you can actually differentiate those components, and you can actually focus on one of those or maybe a couple of those if you need. And that's what I did. Actually, I will explain shortly. These examples, for example, executing a .NET Sharp binary, .NET assembly simply, another Sharp code, a kind of .NET source code, C# source code, exec for the process or PowerShell automation. They are features that you can take out as a kind of function. But you also need to add evasion tactics, because eventually your repository will be open. For example, Patak is out there for almost 2 years, and it is signatured in different levels. Its name, its binary, its source code. So you need to change things. You need to hide some content. You need to perform obfuscations, or you need to add layers such as dropper, then a loader, then a shellcode, full implant, and then adding additional modules on the implant. This journey is a long path. And if it is identified by a kind of malware reverse engineer, the engineer will see only one of those, or whatever you loaded in memory, but not all the phases of the exercise. That's why what we are trying to do is making things harder for them, because adversaries already make it harder. So we need to train our defense in that manner. We can also add detections for automated analysis as well. We can force the analysts to take it in person. We can detect the sandbox. We can avoid virtualization. We can refuse debugger environments. So those are the things that we can leverage to make things harder for the analysts. I developed a new project, the blunt entlantment, and there is no documentation for it yet, but the repository is there, TBI. So you can go to my GitHub and you can find this one. And I still have a limited understanding of what I will do next with that, but currently it works just like in this one. It actually grows in memory. It has some functionalities, core functionalities, such as running instructions or loading a module from an image in a mode. So if the module is, for example, sample module, it looks for get instructions and operate, and it actually get instructions to extend the menu and add the menu items, and then operate to run those instructions in that new module. So it doesn't know what modules are there and how it is developed. What it is interested in is actually get instructions and operate. So it's a good example, and I used legitimate websites to actually drive this tool. For example, image website, because I hide my content in images. Those images are simply having the bytecode after the end of file, and they have actually XOR key as a part of it. So XOR key is the separation, and after that, the bytecode is there. Actually, not bytecode, bytes, simply byte array. So byte array is a binary content that we don't know. It is a text file, such as config, or an internal module for TBI modules, or a shellcode to inject. And TBI actually loads these components from this image service and then adds additional stages or additional features to run some assembly to extend the features, for example, using assembly components. It bypasses MC, it provides you interactive WebSocket, it gives you injection opportunities, so you can use Donut or Cobalt Strike injections. So it uses legitimate websites, and you can drive this, and the components are actually growing in memory. So you don't need to ship everything at the same time. And they are a part of the same environment, and you can interactively grow them. These are the sample commands, such as load module from a remote location. The type is image. The type could be a local file as well. That is also fine, or XOR file. So it's up to you how to design this, because there is a deployment script there that you can choose. When you load the module, that menu features the instructions available in the module, such as disable it, available for antivirus bypass. Exec assembly image is available for the assembly module, or injector module has injector or inject XOR, inject image. So you have multiple options, so you can use it. This is a simple example of this execution. I have recorded this video in our internal The Missing Link event. So simply, it's a very short video. Deployment SH compiles everything for us. And you have a compiler there as well, but you need to customize it. And it is not error-free, believe me. When I used the WebSocket, as I previously demonstrated, the service is running there. I'm currently using process config, and it will process a config file given. So the TBI is running, and it will look for a URL and then XOR key, for example, KeyMe. So it will download this PNG file, which is an image, and it will use KeyMe to actually decrypt this XOR, and then it will run the commands inside. The commands are simply load assembly features, load WebSocket, and connect to the WebSocket and give the content. As you see, it is connected to our WebSocket, and that WebSocket module is there. But there are other modules, and initially it didn't have any connect command, but now it has because of this module. And now we are using load module file, KeyMe, again, the XOR key simply, and antivirus bypass module. And this module could be a remote module or local one. In this case, it is file, XOR file, instead of an image on the remote service. As you see, the module is loaded now, antivirus bypass module is there, and disable it is available now, which is a new command that can disable the antivirus. So we have multiple modules here, but you also need some essential features such as SWC, IMG test, and XOR enc. That helps you, actually those help you to encode something, encrypt something, add some features, and etc. So they are Swiss Army knife and knives for you to develop additional code segments. So you can hide your activities in plain images, just like stenography, but in a poor way, poor man's stenography simply, after the end of file components. And it will be a part of the PNG, JPEG, or other files, and you can use legitimate environments such as image share. Simply, we need to remember always, tradecraft development requires trade intelligence data. We are not developing this in the wild and just without no information. We are making it through the threat intelligence data because we hear something and we try to make it sense. That's why we develop those tools. Adversary simulation packs provide actually examples for various components: antivirus bypasses, evasion tactics, executions, injections. So seeing an adversary simulation pack is quite valuable. So you can investigate every layer of it. So find your favorite language and start developing. That's what I'm suggesting always. From beginning or from in the middle of it. Just changing the code segment or start with a hello. It's up to you. But development really helps for adversary simulations. These are my references for this talk and the content. So it will help you to understand how I develop my tools and my components. I hope this can satisfy a couple of questions in your mind anyway. And feel free to ask more questions. So this is a recording. I'm not sure how I will get the answers, but it will be announced in the BScience pod. So I appreciate you if you ask questions, and I will try to answer them live or through LinkedIn or GitHub. You can, of course, register your questions or issues as well. TBI is still proof of concept. I haven't decided what to do with that. So you can use TBI, but don't expect any support yet. I will decide what to do next, and then I will inform you as well. Thank you for your time. Thank you for listening to me. And thank you, BScience, for hosting me for this presentation. Have a great one.